We're going to talk about some basic concepts of solution chemistry, where we're going to be mainly focused on the solutions themselves and what makes a solution. One thing we have to consider with solutions is whether something's an electrolyte or a non-electrolyte. By definition, if we have an electrolyte and a strong electrolyte, that means we're going to have ions present in solution. And because we have ions present in solution, that solution is going to conduct electricity. If I look at a non-electrolyte isn't going to have ions present in solution. But with non-electrolytes, it doesn't mean they haven't dissolved. It just means when they've dissolved, they don't form ions. Because we don't have ions present in solution, we're not going to conduct electricity. And then we'll have somewhere in between where we'll get some ions formed when a compound dissolves, but not as many as we would with a strong electrolyte, so we call that a weak electrolyte. Weak electrolytes still conduct electricity because they have some ions in solution, but they don't conduct it as well. Now let's look at what happens to a compound when it goes into solution. So if I take sodium chloride, NaCl solid, dissolve it in water, that NaCl solid will break up into its ions, into the Na plus and the Cl minus, and we put aqueous, remember, because it's dissolved in water. Now when those dissolve in that solution, we have to have the number of positive charges equal to the number of negative charges. In other words, we need electron neutrality in that solution. We can't have these charged solutions. Alright, just a cartoon of this. If I've got 4 NaCl molecules or formula units, and I put all 4 NaCl molecules into the water, they will all 4 break up into their component Na plus ions and Cl minus ions. So 4 NaCls go in, I get 4 Na pluses and 4 Cl minuses in solution. Okay, that's the process when a strong electrolyte gets dissolved in water. Alright, a little bit prettier picture of that, showing the same thing where we're going to get Na plus ions and Cl minus ions in solution. That's what makes this an electrolyte. Now before we get too much more into electrolytes, non-electrolytes, let's talk about the actual process of dissolving. But first, in order to understand that, we need to talk about something called polarity of water. What you need to be able to recognize is water is going to be a polar molecule. What we have is what we call a slightly negative side, slightly positive side to water. Those little deltas, lowercase deltas, so delta minus, delta plus, those represent slightly negative, slightly positive areas. Okay, so water is a polar molecule. It has a negative side, it has a positive side. How is that going to affect how we dissolve a solid? Well, if we go back to our example of sodium chloride, if we look at those pluses and minuses as the plus is the sodium ion, minus is the Cl minus ion, in order to break those apart from the solid to get them to dissolve, we have to surround them with water molecules. Now when you look at these water molecules here, you see an arrow with what looks like kind of a plus on one side and then the arrowhead on the other. The arrowhead represents the negative side of the water molecule. The plus side represents the positive side of the water molecule. So you notice these water molecules, as they get close to that positive ion, that Na plus, the negative side gets attracted towards it. And then the positive side gets attracted towards the chloride ions. As more and more water molecules start to pull on that Na plus gets surrounded by more and more water molecules, and when enough of them surround it, it goes into solution. That process of surrounding that ion is called hydration. If you hydrate yourself, you're actually consuming water and you're putting water into your system, right? Well, it's the same basic idea. We're hydrating it, we're surrounding it with water. If you look at the chloride ion then, it's surrounded by water as well, but it's got the positive side of the water. Okay, so this is part of that dissolution process when we're dealing with ionic compounds. A couple other terms you need to recognize. You need to recognize solubility, which is how much of a compound can dissolve in a given solvent. We have to worry about solute. Solute's what's being dissolved. Solute is going to be in the smaller amount. Solvent is going to be what's doing the dissolving. It's going to be present in the larger amount. So if I take sodium chloride, dissolve it in water, sodium chloride's a solute, water is a solvent. If I take something like 5 milliliters of water and mix it with 300 milliliters of ethanol, then water's a solute, ethanol's a solvent for that particular mixture. Alright, so keep in mind, in this dissolving process, we have to have that solvent attracting to the solute to pull it apart, and those attractions need to overcome the solute-solute interactions. If the solute-solute interactions is larger than the solvent-solute interactions, the compound isn't going to dissolve. Okay, so keep in mind when we're dealing with this solvent-solute interaction, in this case, it's between that water molecule, that negative side of the water, and the positive sodium, positive side of the water, and the negative chloride. The solute-solute interactions between the Na plus and the Cl minus, that electrostatic attraction there. Now, some more terminology we have to worry about. When we talk about adding sodium chloride to water, sodium chloride dissolves in water. In other words, it breaks up into its ions. But those ions were already present in that solid. It's already an ionic solid, so we already have Na plus and Cl minus ions in that solid. When it dissolves, they just break apart. But when we look at HCl, HCl is an acid. We know it forms H plus and Cl minus in solution. But technically, HCl, that's a covalent compound because it's nonmetal with nonmetal. But we're still going to get ions in solution. So when we say we take this compound and dissolve it in water and get ions in solution, we say it's ionized. Now, a lot of times when we write HCl dissolving, it forms H plus and Cl minus. In reality, HCl is going to react with some of those water molecules to form what we call H3O plus and Cl minus. So you'll see the H plus and H3O plus, they'll interchange a lot. Okay, so when you see H3O plus, that's something called the hydronium ion. Just means we've taken that H plus and added it to water. Because if you think about what an H plus is, if I take a hydrogen atom and remove an electron, it's nothing but a proton. So that's going to be fairly unstable when we add it to that water. It wants to attach to something, it attaches to that water molecule. And in fact, it'll attach to more than one water molecule a lot of times. But we're only going to worry about either writing H plus or H3O plus. So when you see those are interchangeable when we're dealing with these acids. So ionic compound dissolves, and acid is going to be ionized. In terms of solubility, we talked about solubility being the amount of solute that can dissolve in a given amount of solvent. Okay, well, we also need to identify if something's soluble or whether something's insoluble. So something's soluble, obviously, it's going to dissolve. It's going to break up into its ions if it's an ionic compound. Keep in mind, if it's a covalent compound, it still may be able to dissolve, but it's not going to form ions in solution. All right, if something's insoluble, for example, AgCl here, we're going to form these solids. It's not going to dissolve in water. And what we'll see is we'll see solid present. So we have that aqueous layer above, we've got that solid down below. That silver chloride is what we call insoluble. So when dealing with solubility, that affects this as well in our definition of what's a strong electrolyte, weak electrolyte, non-electrolyte. We talked about strong electrolytes are going to form ions in solution, weak electrolytes are going to form a few ions in solution, non-electrolytes aren't going to form any ions in solution. Let's start with non-electrolyte here. So if I take methanol, CH3OH, in its liquid form, it'll dissolve in water to form a CH3OH aqueous. If I take 3 molecules of that methanol, dissolve it in water, you notice inside the water I still have 3 molecules of methanol. That's what makes it a non-electrolyte. It's still dissolving, but it's just not forming ions in solution. So a picture of another compound here. You can see these molecules. Got a lot of carbons, hydrogens, oxygens. It's an organic molecule. It's not forming ions in solution. It's still staying in the water, though. It's still dissolved in that water. Okay, so let's look at strong electrolytes now. So non-electrolytes don't form ions in solution. Strong electrolytes are going to form ions in solution. And whether we deal with HCl forming H plus and Cl minus, or sodium chloride forming Na plus and Cl minus. So if I take 4 HCl molecules, dissolve it in water, I'm going to get 4 H plus ions, 4 Cl minus ions. That makes it a strong electrolyte. However many moles of HCl we're putting in, we're getting that many moles of each individual ion out. That's a strong electrolyte. Let's look at what makes up a weak electrolyte then. If I have acetic acid, HC2H3O2, form H plus and C2H3O2 minus, we could represent that forming the H3O plus and the acetate ion as well. The thing about acetic acid is it's a weak acid. Now what a weak acid actually means is we have an equilibrium formed. So as some of the acetic acid molecules break up to form H plus and the acetate ion, some of those H pluses and acetate ions recombine to form the acetic acid. And so that goes back and forth. Ultimately, overall though, what that means is if I take 4 molecules of acetic acid, I only get a few of those to actually break up into ions. So out of the 4, if I only have 1 break up into its ions, it's still going to be an electrolyte because it's going to have ions in solution to conduct electricity. It's just not going to be a strong electrolyte because not all of the molecules put in break up to form ions. Notice though, everything that's put in is actually dissolved. It's not like we're forming a precipitate or anything. All of these molecules that go in, they all dissolve. It just only some of them break up into their ions. Prettier picture of that. So when considering electrolytes, they're going to conduct electricity. They're going to conduct electricity because they have ions in solution. So with strong electrolytes, we're going to have things that will completely dissolve or ionize when put into solution. Now when we get to strong electrolytes and we're talking about acids or bases, typically we call those strong acids, strong bases. So like HCl and HNO3, those would be considered strong acids. When we look at weak electrolytes, those are going to be compounds that are going to be slightly soluble. They're not going to dissolve or ionize completely. They're still going to go into solution, but they're not going to form as many ions. When we talk about the acids here, we've got hydrofluoric acid, acetic acid, nitrous acid. When we talk about those acids, we'd call those weak acids. For the magnesium carbonate, it would be a weak electrolyte. Magnesium carbonate is actually an insoluble salt. Then we have the non-electrolytes, the things that are definitely not going to form ions in solution. When you look at these non-electrolytes, a lot of them are molecules that contain carbon, hydrogen, oxygen, nitrogen. Those are what we call organic compounds. So a lot of those organic compounds will be non-electrolytes. So keeping in mind the idea of electrolytes, electrolytes are going to form ions in solutions, non-electrolytes are not going to form ions in solutions. They're still going to dissolve. We want to get this concept down and be able to predict ions that are going to be formed in these solutions. So, what ions and how many are going to be formed if we look at the following compounds dissolving? If I look at copper 2 chloride, if I have 1 copper 2 chloride, I'll have 1 copper 2 plus ion, and I'll have 2 Cl minus ions. If I have sodium phosphate, when I break those up into their ions, I have 3 Na plus 1 ions and 1 PO4 3 minus ions. Let me start with a name, tin 4 chloride. Well, before I decide, I want to get the formula first. So because tin is a plus 4, I'd have 4 chlorides. So I'd have 1 Sn plus 4 ion and 4 Cl minus ions. Alright, what about C2H6O? Chances are this is a non-electrolyte. Remember, carbons, hydrogens, and oxygens, when we see those are pretty common non-electrolytes. So we're not going to form any ions. We're not going to break it up into carbon, hydrogen, and oxygen. It's just going to stay together as that whole molecule. What about NaC2H3O2? Well, now we definitely have an ionic compound because of that sodium. So that's going to break up into the Na plus and the C2H3O2 minus. So we always have to be thinking about what ions are going to be formed in solution from these formulas, if any, and then how much of each ion is going to be formed. Because that's going to help us determine concentrations of these things in solution when we get to talking about that.